Before considering another algorithm, let's reflect and remind ourselves why Dijkstra's algorithm works. What we're trying to find is the shortest distance from x to y for any x and y. Let's name that quantity d sub x, y. That's what we're trying to get to. When we start out, the only thing we know is when x and y are the same, the distance from x to x is 0. Definitely the shortest path, because we're assuming non-negative paths. The other thing we know when we start out is the cost of going from v to any immediate neighbor y. So we're assuming that routers know their immediate neighbors, and they know the cost of that one hop to that other neighbor, and what we're trying to figure out is the cost more globally across the graph. The argument for Dijkstra's then relies on this lemma here that says the minimum distance from x to y must be the same as the minimum distance from x to some v where we can get from v to y, considering all possible v's. So all the v's that we can reach from x to v, if we consider the extra cost from getting from v to y, one of those must be the cost from getting from x to y. Because to get to y, we have to go through one of its neighbors. And so if we already know the minimum distance for all of those neighbors, we must know the minimum distance from x to y. So how does Dijkstra's achieve this? Let's define v now to be the set of nodes for which we found dx of v. And we start out by knowing that dxx is just 0. That's all we know in addition to c. So we know just initially dx of x, but this set will grow. In any case, we can take what we know so far and consider all of the y's that we can reach through one more step from the things we know. So all the possible x, y's that we can get from our current dxv's plus connections from v to y. And we pick the smallest possible one that we can add to our set. That must be the correct one, because we've always picked the smallest thing we could so far. Anything we do in the future that's based on our pick, our new xy, must be longer than any path that we've picked now, because it's going to build on dxy, or it was one of the things we should have chosen already. And so what that means is every time we pick the smallest thing, and every pick after that gets bigger, then we're never going to find a smaller route later, and that means that when we run out of things to pick, we will have gotten the right answer always.